Let's review my example solution for day 5's assignment. Our concat method is fairly simple and merely needs to check if the first and second parameters are in fact arrays. If they aren't, throw an error message. We can use the array.isArray method in order to check whether an object is an array. If the passed-in parameters are arrays, we can call the concat method that exists on the array type and pass the second array to the first. We then return the result of this operation, which is a new array. Our tests for this method should check that when passed two arrays, the output is as we expect. We can use the toEqual matcher here to check the output matches an array containing 1, 2, and 3 when we've passed in two arrays containing 1 and 2 and another array containing 3. We should also test that when we try to call our new method without an array in the first position, this should throw an error. You should have discovered that you'll need to wrap the call to concat inside an additional function in order to catch this error. We also write another test for the second parameter. Our addProp method takes 3 parameters: an existing object, the name of a key to add to that object, and the value to assign to that key. If the key already exists on that object, we'll throw an error. We check for the existence by just passing the key name into the object and looking at the property here. If an error isn't thrown, we copy all of the existing properties on the object to a new object using object.assign. Then we add the new key with the expected value to the object. We then return this new object. Our tests consist of checking that the returned object has the property that we expect and that it has the value that we passed in. So we create an object with a single property, add a new property called num with a value of 5, and then expect the returned object to have a property of num with a value of 5. This is using the toHaveProperty matcher from Jest. Our final test checks that the function throws an error if the object already has a property of the name. So we construct a new object with a single property called hello, and then we try to add a new property called hello again to the object. Obviously this property matches the existing hello property, so this should throw an error. Hopefully this assignment has helped you be more confident with your unit tests and learn a few extra matches from the Jest library. Section 6. Async await. Advanced asynchronous operations. During day 3, we briefly covered promises. Today, we'll cover them in more detail as we lead up to ES8's async await functionality. After we refresh ourselves on using promises, we'll also look at handling promises in sequence, destructuring the result of running multiple promises, and running promises in a race. Let's refresh our promise knowledge. Let's make a function that returns a promise. This function will set a timeout based on a parameter that you pass. And then after the timeout has expired, it will either resolve or reject your promise based on random chance. As we can remember from a previous video, we can now attach a then handler to catch when this promise resolves, or a catch handler to catch when the promise rejects. We can also group these promises together and run them in parallel using promise.all. And then attach a then handler that will resolve when all of these promises resolve, and attach a catch handler that will catch if any of these promises throw an error. Don't forget that promise.all will reject if any of these promises reject. It's also possible to run our promises in a chain. And this second then will only run if this promise resolves, which only runs if this promise resolves, and so on and so forth. As long as each of our handlers returns a new promise, we can attach an additional then and handle either a resolution or a rejection. We're all caught up on promises, so let's move on and see what else we can do. If you have lots of promises that you want to run one after the other like a chain, but you have a dynamic amount of promises, and so you can't hard code your chain together, you'll need to write a sequence handler. In this pattern, you run a function that returns a promise, and upon resolution, the next function in the sequence is called. These promise returning functions are run one after the other. We can't just pass an array of promises, we need to pass functions that return a promise. Executing these functions and starting the promises off is the job of the sequencer. Let's just write a new promise returning function. A sequencer works by taking an array of functions, with each of those functions returning a promise, or indeed calling another function that also returns a promise. First, our sequencer sets up a promise that is already resolved. And it resolves with an empty array. Now we'll return this promise at the end of our sequencer. Now all we need to do is iterate all of the passed in functions and execute them one by one. We'll iterate using a for each loop. It's also possible to write the sequencer as a reducer, but for eaches are a little bit simpler to explain. So for every function in the array, we're going to attach a then handler to the promise object that already exists up here, and we're also going to overwrite this promise object with the result that we return. We need to have access to the results of the promise object, so we get this here, and on the first loop of the array, this results object will be this empty array. Our then handler now needs to return back another promise so that our promise object is overwritten with another promise object. Luckily, each of the functions that we're going to take in as an array will return a promise, so we can execute the function and just return its value. But if that was all that we did, then the output of the sequencer would only ever be the last value returned from the array. But if that was all we did, then the output of the sequencer would only ever be the value of the last function that we run from the array. We need to gather up all of the return values, and this is why some people would write this as a reducer. So let's attach another then handler to this function and gather up the new result. And then we'll take this new result and attach it to the last set of results that we got. So now that our sequence is written, let's see how to call this. We're going to construct an array, and we'll fill it with functions. And these functions are each going to call the function that return a promise. Now these particular promises, when they resolve, they'll resolve with the timeout value that we pass in, just so that we can see that each of the resolutions has a different value. Now that we've defined our array, let's call our sequencer. We'll try running this. As you can see, we end up with one array containing the three values from running these three functions. If we extend this delay, this should take 3, 4, 5, 6 seconds to run, which it does. Perfect. Now that we've started running promises in groups, whether in parallel using promise.all or in series using our sequencer, we need to handle the array of results that we receive back. Historically, this has meant using array indexes and reassigning variables. Do that like this. And so on and so forth. While this works, it's not a particularly elegant solution, and with destructuring, we can make this look a lot simpler. Instead of directly accessing the array using its index, we can instead destructure the returned array. Let's try and log these values individually. And as you can see, we've managed to get these values out of an array into individual variables that we can access. This is so much cleaner and it's much simpler to understand when you read through the code. Promise races are a fairly simple concept. Much like promise.all, this method takes an array of promises, but unlike promise.all, it won't wait for all promises to resolve before it resolves itself. Instead, as soon as the first promise resolves, promise.race will resolve. The other promises are still running in the background, but your .then handler attached to the race promise will resolve and move forward. So let's have a quick example. We'll make another promise returning function, and then we'll race these. So this will race a promise that takes a second to resolve, a promise that takes 20 milliseconds to resolve, and a promise that takes 3 seconds to resolve. As you can see, that 20 millisecond one resolved immediately, and therefore we got our result straight away. You might have seen that Node was still waiting for this 3-second promise to complete before Node exits. That's because this promise is still running in the background, even though our then handler has been fired. So in this video, we've extended our knowledge of promises.